Okay, guys, so today we're gonna discuss about the speed time graphs and distance time graphs. So actually we have the modules already, but I'll give you the explanation about the distance time and speed time. What are the difference? Actually, distance time and speed time graph is the application of the graph and the functions. Okay, let's see. Distance time graph first, the easiest way, easiest graph. So distance time graph is the connection between distance and time. So in a movement or in kinematics of an object, we travel in space and time, right? So the dimension is for the distance is space and the time is time itself. So space can go backwards, we can go left, right? We have the positive and negative sign for the distance because actually this for displacement, but for the time it is always moving forward. Therefore, if you want to make it in an order, we have a vertical axis and horizontal axis, which the horizontal axis is only exclusive for time. It can be in unit of seconds, minutes, hours, days, but we usually use seconds or hour. Okay, we use second or hour. And for the distance, depend also. Distance on the vertical axis, it can be in the unit of meter if the time is second, meter over second later for the speed. And then we have kilometer in hour. So we use the international standard. We are not using the imperial units. Imperial units means feet and then inches and so on. So we ignore this because we are not using the American way. We use the England standard, right? The international standard. So can you imagine what happened with the graph if the object is moved like this? What happened to the line blue? What happened to the object of the blue? So it moves at a constant speed, right? Why? Why can you explain? Why you can say that it moves at a constant speed? How? How do you understand this? How do you make sense of it? So they travel. Let's say I want to split in a certain of time here. I want to make a chunk. Chunk means the small cuts, small part of the time. And I want to increase this. Let's say this is distance one for time one and time two, and this also distance two, and time three for distance three, and so on, right? So if it is a straight line, therefore, we can say or we can see that the gradient is constant. Yep, the gradient is constant. Or for the difference of the time, which is this time, right? The distance traveled is this, right? The yellow color. If it is not clear enough, I will make it a bit thicker here. And another same chunk, same cuts or same length or same period of time from T1 to T2, which is equal to 0 to T1 here. The distance traveled or the distance change is this, right? Only this. And they are the same. So we can conclude that the same distance on the same period of time, we say that it is a constant speed. Quite simple, right? So let's do the other logic. How about if we have this line? There, what happened? Not moving. Why? Because at a certain time, the position is always at this point. Never change. So it is not moving, or we can say it is a stationary object. Okay? Does it make sense? Understand, yeah? How about this? The yellow, the red color. Accelerating. Oh, nice. Why accelerate? How can you explain the object is accelerating? Oh my goodness, the gradient is changing for every time. Okay, that's the technical way to say. Are there any simpler way to understand about this accelerating? Using the speed and time, using the distance and time only is enough. So 0 to T1, T1 to T2, the distance changing is getting greater. Let's say T2 to T3. See, it is increasing by the time. T3 to T4, way more increase. See? So as you can see here, the T4, wait, not T, distance 4, distance part 3, the distance 2, distance 1 are increasing by the time. So we can say it is an acceleration. Okay. Let's do the next part. What other color that we haven't used? Blue, red, yellow, purple, pink. How about this? Careful, yeah. Ridley, you may hold your answer. I'm asking for other colleagues might be or another students. What happened about this? Deceleration. Yes, that's right, Kimi. How do you say it is a deceleration or retardation? Yeah? Distance is decreasing over the same period of time. That's right. So deceleration. Double C or single C? I forgot. Ah, double C. Deceleration. Or we can say that it is retardation. Not getting more stupid, yeah. Retarding. Retardation is getting slower. So we are not trying to personalize this term. Retardation means getting slower by the time. Actually, human also getting retard, right? Getting slower by the time. Slower, but all the workings, all the things they do were so effective by the time also. So we can try to impersonalize this topic. So distance time graph. So we are talking about the distance. Are there any questions so far? No? Okay, so this is the simple understanding or simple explanation of distance time graph. Now we're gonna go for the speed time graph. Wait, I mistyped this distance time graph, distance time for the simple way and speed time graphs. Okay, so we're gonna go for the distance for the next, which is speed and time graph. Let's see what we can do here. Now we are focusing on speed time graph. Now this is gonna be more interesting. Why? Because we are considering the speed. Okay, as always, speed is a vector unit which has the direction, and time is a scalar unit which has no direction and it is always going forward or an absolute value. So the time is always on the horizontal axis. Always keep in mind horizontal axis or x-axis for the time, and this is for the speed, right? So let's see how it can go. Meter over second or kilometer over hour. Time is seconds or hour. They depend. So, however, if we try to think of this, what happened to the graph? What is this graph? How do you explain this graph? Uniform speed or constant speed? That's right. Constant speed. How about acceleration? How do you draw the graph of acceleration? Acceleration could be accelerating. Means what means by accelerating? The speed increase over time, right? It can be like this or like this. depend on the initial speed. So we have the initial speed and we have the increasing speed over time. So this is called acceleration with initial speed. For example, you are on a certain speed in toll road, let's say 20 kilometer over hour. After you stop, not stop, after you uh, hit the gas, you increase your speed. So we have the initial speed. How about this? Acceleration also without, or we can say acceleration from stationary or from rest. Okay. So you want to pay the toll road in Indonesia, then you have to stop it for a while and you tap the card and then the gate is open. After the gate is open, you start to hit your uh or your gas. Yeah. You increase your speed. So from stationary. Now, how about deceleration? Deceleration is decreasing of the speed, right? So you decrease the speed from a certain speed going down. Okay. Or like this. Okay. You can do anything you want. Like this might be, as long as the speed is decreasing, right? Going down. So this is called retardation. This is retardation. How about if I don't, I use this? How about if this kind of graph? So for now, we don't learn about this. Okay. And we have another way to understand this. So it is not only the graph, but also we learn about the features of the graph. Again, this is more theoretical. If we have speed time graph like this, we can calculate or we can find the distance traveled uh, from the graph itself. Okay, for example, this movement only until this T2. Let's say from T1, which is 0, until T, and then in a certain speed. How do you find the distance traveled? So the distance traveled is always speed times time, right? And we can conclude that the speed is this, and the distance is speed times time, sorry. Distance equals speed times time, which is equal to the area, right, under the graph. Make sense? So the distance is equals to the area under the graph. Let make it more interesting. We can go further about this. I will give you some explanation later. I'll put it first. So distance time and speed time is already explained. Distance time, speed time. Now we are focusing on the area under the graph. The area under the graph might not always be constant speed, right? It can be more various. For example, like this. I will give you exact example. Only for speed time, yeah. Distance time, nothing to do with the area. So only for speed and time. Okay, before we try to find the distance, I'll give you some story about this. So from let's say someone start going using cycle, go by cycle from their home, from his house, with a constant speed, constant acceleration, and then after he increases his speed, he tried to walk or he tried to bike with a constant speed as always, and then you get never in your daily life you never speed up always, right? So you have to do the constant speed, and then after constant speed almost arrive at your destination, and then you try to stop at a certain distance, right? At a certain point. And another, you can tell about the story of the speed time also. I'm increasing my speed here, and then I think it is what do you call it is too slow. I want to increase my speed by a constant like this, and then I cannot do the more speed, so I do a constant speed. It is a maximum speed, and then I see some obstacle. I hit the brake, but I don't want to stop. So I want to make this speed and then go here and go to rest. Does it make sense for you? Is it sounds more daily life, right? More natural instead of this. But perhaps we need to understand what does this graph tells you. Let's say this is journey A, journey B, journey C. So what from what I say previously, I want you to explain what happened to A. Technically, mathematically saying A is acceleration, B uniform speed or constant speed, that's right, constant speed. How about C? Deceleration. Okay, that's all what you need to do. What you need to know about the story first. Later in the counting, we try to solve it more precisely. Let's see. How about this? How many journeys? How many types of journey that the object the object travels? How many types of journey? One, two. You can use ABC. One, two, three, four, five, six types of journey. So journey one, acceleration. Journey two, acceleration with more accelerating, right? So you hit or you speed up more, right? How about three? Journey three, constant speed, right? And then journey four, deceleration, but not to rest, deceleration to a certain lower speed. Five, constant speed also. Okay, my handwriting, sorry for the bad handwriting. And then six, deceleration to rest. But uh, we need to make it more detailed. So we know all the journey already. So I will erase this. Don't have to think about this. The question is simple. What is the total distance traveled? What is the total distance traveled? Again, you have to think of the area under graph. So what you need to find is this area. Okay, we can split if the shape is irregular. We can do one by one. You add distance A plus distance B plus distance C. But if you memorize the area of trapezium, why not? Right? So the total area is, let's say this is T1, T2, T3. This is D1. Okay. Okay, focus. What is area of A? What is the area of A, guys? 1/2 why? Because it's triangle, right? Half times base, which is T1, times height, which is D1. Get it? Be careful about question B. What is the area of B? T2 minus T1. Why? Because we are calculating this size only, not T2 times D. Careful. T2 minus T1 times D according to the rectangle rule. We only have one D. Okay, very simple. C, half T3 minus T2. Be careful because this is the base, this is the height. Height is D1 also. Okay, so this is about a triangle area. This is also triangle area. This is a rectangle area. But if you memorize the trapezium area, very simple. So the total distance is, remember, half times sum of parallel side, sec 1, Second one, materials times height. And they will give you the same answer. Sum of parallel side, T3 plus T2 minus T1. Yeah, way more complicated because we are using the variables. We are not using numbers. No. This sum of parallel side is T3 itself, right? And then plus this. What is this? T2 minus T1, right? And then times by the height D1. And you can check. It will be the same. Depend on what you memorize. So the more you memorize, the more efficient you will get the answer to the answer. Okay? Understand, really? So this only. This is T2 minus T1. The sum of parallel side. Okay, the example is finished. So let's go for the questions. I have some questions about this real life graph. So if you look at the Save My Exams topic, it has the real life graph. Okay, let's see. Okay, the question is more complicated than what I expect. But I don't think it is quite hard. It's not too hard to understand. Moment. Okay, let's see. Can you guys focus? Question A and question B here. The diagram shows the speed time graph of a part of a car journey, only part of a car journey. This speed time, okay? Speed and time. Find the deceleration between 10 and 13 seconds. So you are finding this deceleration. So in speed time graph, deceleration or acceleration can be found by finding the gradient. Okay, so deceleration or acceleration can be found by using gradient. If the gradient is positive, it is acceleration. If the gradient is negative, it is going down, which means deceleration. Deceleration 1c. Okay, I just need it. 1c. Okay, find the deceleration between 10 and 3. So first thing first, you need the points, 2 points, 10, 8, right? And then this is 13,0. But the gradient is not x1 minus x2, but this speed 1 minus speed 2 or speed 2 minus speed 1, yeah. Be very, very careful. So the acceleration, you guys wake up, wake up. The deceleration is speed 2 v2 minus speed 1 or last speed minus initial speed, subtract t2 minus t1. So a gradient form, but not not x2 minus x, not y2 minus y1, but x2 minus x1. Better use the speed. Yeah, y2 is 8. Sorry, 0. v2 is 0 minus 8 over 13 minus 10. So negative 8 over 3. Actually, this will be produce you the same formula with gradient. So I want to revise my words. Still y. It's the same, yeah, constant. Okay. It's still the same. Speed subtract by over time. Speed over time. So speed is y, time is x. Therefore, it is still consistent. Sorry, guys. So the previous words, previous explanation focus on the speed, yes, but it is still in a consistent way with the regular formula on gradient. Okay, negative 8 over 3. What is the unit? Meter over second square. Okay, meter over second square. B, calculate the total distance traveled during the 13 second. I will use two ways. First way is you break down two areas, area 1 or area A plus area B. Area A is 8 times 10, length times breadth, or yeah, width times length, anything, or 10 times 8, up to you, 80 meter. Area B is the triangle rule, half times base, which is 3, right? 13 minus 10. We do it like this. You don't have to put 13 minus 10, wasting time. times 8, 12, right? Add all the numbers, 92. That's all. Now, about the distance total. About the distance with the other formula, we use the trapezium. Trapezium formula is half times A plus B. Remember what is A, what is B? A and B are two parallel sides times time, right? Or times height, sorry, times height. So half A is 10, B is 13, right? 10 plus 13 times by 8. You can cross out the 12, 2 and 8 becomes 4. 23 times 4 is 92 meter also. Way simple, way more simple. You can choose either using the breakdown rule. If you break down, you only get either rectangle, square, or triangle. But if you do the trapezium, it will be making you more efficient and less time taken to do, as long as you memorize the formula. Okay, that's for the this speed time. One example is explained. Let's see the other questions. You can see it also from your modules. Wait, where is it? Here. Okay, one more, yeah. One more. Hmm? Oh, just now. Wait, here. Eh, there you go. So the deceleration and acceleration is always gradient for the speed time. For distance time, the gradient is speed, right? Distance time, gradient, distance over time, speed. For speed time, speed over time, acceleration. Okay, shall we continue? Okay, next. Okay, now we're gonna go for the formula that we haven't learned previously, but I think you already knew it in your secondary level, Sec 2, Sec 1, but let's see how it is done. I will make the graph more clearly seen. There you go. Okay. Find the duration. The duration means the time which the car is not moving. This is the distance time. Be careful. Distance time. When? What is the answer? Duration, 1 hour. How can you say? From here to 2.5. So the duration, 1 hour. The question is, find the period. If this is the duration, very simple. Duration of rest is 1 hour. My question is, so about the duration is 1 hour, good. But the more complicated answer, what is the period of rest between 1.5 to 2.5? Do you know what's the difference? Do you know what's the difference between duration and period? The duration is only the time taken, and the period is from time something to time something. Okay, we try to elaborate the duration. When is the 1 hour happens? Right after the car moves, 1.5 hour. It stopped for 1 hour. It can you can say it like that also. Okay, be careful, yeah. There is no such question for question A here. I'll give you an extra question about this. Differentiate between duration and period. Period is about the time frame from T something until T something, right? The duration is T2 minus T1, of course. 2.5 minus 1.5, 1 hour. B, find the average speed of the car in the first 2 hours of the journey. Average speed is total distance, no matter what type of the movement they go, total distance we look at from the beginning to the end. Over time, over total time. Total time. Wait, total time. That's for average speed. Total distance in the first 2 hours of the journey. So we have to stop not in the 3.5, but at here. What is the distance traveled until this point? 60, right? Also, only use 60 over time, 2. So 30 kilometer over hour. That's all. Total distance over total time. You will get this more interesting when you look at the distance time. Speed time graph, sorry. Speed time graph, average speed is more interesting and more complicated to do, but I think we can do this soon. Yeah. So for this question, we are finished. We continuing we are differentiating between duration and period, and we know one more formula, which is average speed. Let's go for the next part. Speed time. Okay. Right. Number 5. One last question, and we can finish all the topics. And that's all what about the speed time and distance time. The diagram shows the speed time graph of an object which travels at a constant speed 36 meter over second and then slows down at a rate of 12 meter over second. What is this? Deceleration. Okay, slows down at 12 meter over second. Negative 12. Keep that in mind because it is decelerating, going down. The gradient is negative. Coming to rest. Rest means 0 speed, stop and all. Find the value of t. Okay, it's getting more complicated. The deceleration happens from 6 to t, not from 0 to 6, right? So the deceleration happened on the second type of journey, which is this. Make sense? Not this, yeah. This is a constant speed. So you are trying to calculate this gradient. Oh, we have the gradient already. So the m equals, or the deceleration A equals V2 minus V1, speed 2 minus speed 1 over time 2 minus time 1. The deceleration is given by 12. Sorry, negative 12. So you put down on the formula negative 12 equals V2 0 minus 36 over T minus 6. Can we get the T? How? Cross multiply? Sure. You can, or you can do by, yes. Sure, that's also a very good way, right? So to get T minus 6, you just divide negative 36 over negative 12, right? As simple as that. T is 9, not in scale, right? Or if you insist to make the cross multiplication, why not? Or you can multiply everything by T minus 6. That's I usually do. This is the right way. Cross multiply is the shortcut actually, but this is the smart. This is the concept or the basic concept of how do you do cross multiplication, right? And then minus 36. T minus 6 equals 3, right? Because negative 36 over negative 12. T minus 6 is 3. T equals 9. There we go. What is the unit? Second. Not 5. Seconds. There you go. T is 9 seconds. So the drawing is very, very bad in the scale 0 to 6, 6 to 9. Doesn't make sense. But again, we are not talking about the scale. So it is not in scale. B. Given that the distance traveled, be careful of the question, be careful of the question, need to be very, very extra detailed. The distance traveled when the object is slowing down is 54. So where is the 54? This, right? Understand? When it is slowing down. So the area is 54. So this is 54. not whole. Okay, that is 54. We can say that this is 9. Find the average speed of the whole journey. Okay, so we have to find the other distance because the average speed formula equals the total distance the same way over total time. The total distance traveled is 54, but it's not nonsense if you think that this is 9. So question A and question B are separated. Look at this. How about this? Is it right? 3 times, wait, is it right? Half times base times height. Oh yeah, that's right. Okay, so it's consistent then. So A and B are connected. Uh, the area half times 3 times 36. Oh yeah, that's right. So it's still consistent. Actually, can we just ignore this? Find the total average speed. Yes. So, but this question is giving you an extra bonus question. Total distance is something plus 54. You need to find the D1 first. Distance 1 or area 1 over total time 9. Total distance here is 36 times 6. Very simple. 36 times 6 because area of rectangle 36 times 6, and you may calculate 216 plus 54. Yeah, thanks. 370, yeah, over 9. 270 over 9. Thank you. Oh, goodness. So 30 meter over second. That's it. Okay, any questions so far? So all is given later, and then we are finished. So I'll see you later, guys. Bye bye.